Hey everybody, it is May 18th and I've got our new IXL things posted, the suggestions for you on Dojo. All the different suggestions do have a link with them. So you can click on those to give you some ideas of which ones to work on. But I've also got this video that I'll go through all of the different ones the way I would usually teach them in class. So without further ado, let's take a look at what we've got for this week. So here they are. I tried to make this really simple, so I tried to make it, you can see the division part, and you can see which one of division you need to do. It'll be the seventh one, and that's divide two digits by one digit numbers with word problems. So very similar to last week, only this week it's got word problems with it. So you have to kind of figure out what to do with the different numbers and what to do with the remainders. Comparison word problems is just deciding whether you're using addition or multiplication. You're going to make the number bigger. Are you dealing with sets or are you dealing with just a total? We're going to look at data and graph. We're going to interpret some line plots. So I'll show you guys some line plots and help you guys read them so you can interpret them correctly and figure out what's going on. We're dealing with fractions and with denominators of 10 and 100. So we're dealing with things like 1/10 is equal to 10/100ths, things like that. And also two-dimensional figures. So parallel, perpendicular, and intersecting. I'll try to give you a quick review of what those three terms mean so that you can answer the questions well on IXL. The first one that I have is the divide two-digit numbers by a one-digit number, and this is word problems. So when we do these, I've got a longer video on just division. You can go back and check. I had it posted last week as well, but it's in, I'll have it linked here as well. And you can look at that if you're just wondering about the division part. But I'll go through a few different word problems and hopefully help you guys be ready for those. So I actually have three different examples from IXL, and I'll kind of go through those with you and give you some different strategies to solve. So let's take a look at the first one. This one says, an electrician needs to buy 36 light bulbs. The light bulbs come in packages of 8. How many packages should the electrician buy? Now this one's kind of nice because it's, if you know your facts with 8, this should be a little bit easier. So if we go 8 times 1 is 8, 8 times 2 we know is 16, 8 times 3 is going to be 24, 8 times 4 is going to be 32, and 8 times 5 equals 40. Now we need 8 and 36. We're looking for 36. It would go right here. 36 would be between 4 and 5. So we just need to figure out the correct answer. Well, if the electrician buys 4 packages of light bulbs, he'd have 32 light bulbs. That's not enough. He needs 36 light bulbs. So how many packages does he need to buy? Well, he's going to have to buy 5 packages to have 36 light bulbs. Now, he'll have 4 extra light bulbs. He's going to have some left over. But it's only giving us the option to buy them in packs. And if he needs to buy 36, he's going to have to buy 5 of them. So 5 would be your correct answer. So now, let's take this and take a look at another one. This one says, a group of 86 students are going on a rafting trip. If each raft holds 7 students, how many rafts will the students need? We can do this a few different ways. One thing we could do is we could start kind of drawing this out, and you could draw a raft and put 1, 2, 3, 4, 5, 6, 7 students in it. You could draw another raft and put 1, 2, 3, 4, 5, 6, 7 students in it. And now you'd have 14, and you could keep going up. It's just really inefficient and it'd take a long time. I think another way to look at this would be, again, if I know we need 86 students, there's 7 in each one. If we had 7 students in 10 rafts, that would be 70 students. If we had 7 students in 11 rafts, that would be 77. If we had 7 students in 12 rafts, it's 7 more. I'm just going up by 7s here. So if I go 7 more, then 77. I would get 84. I'm getting really close. So 7 times 13. Again, I'm just adding 7 to each number. So 84 plus 7 is going to be 91. So, again, similar to the last problem, if they have 12 rafts, they can't get everybody on. We're not going to just leave 2 students behind. That'd be kind of mean. So they're going to need 13 rafts. Now, the last raft wouldn't be full, or you'd have some rafts that wouldn't be full, and that's okay, but you need to get everybody on. You need to figure out what to do with that remainder. And so in this case, again, we're going to round it up because we need to get everybody across, right? If the question was how many full rafts will they have, the answer would be 12. But they want to know how many rafts they need total, and so the answer is going to be 13 rafts. Now, you could have also easily done this by going and doing this the way that we did in class with partial products division. And I know that 7 times 10 would give me 70. I'd get 16. 7 times 2 would give me 14. I have 2 left over. My answer would be 12 with a remainder of 2. But again, you can't have part of a raft, so you're either going to need that 13th raft or you're going to leave people behind. So either way you do it, you're going to need 13 rafts. And now we'll take a look at the last example I have for this. It reads, a farmer needs to ship 42 pumpkins to a grocery store. If each crate holds 5 pumpkins, how many crates will the farmer need? Again, in this case, we've got 42 pumpkins. We're going to put them into groups of 5. So we're going to divide 5 times what gets me close to 42 without going over. Hopefully most of you know that it's going to be 8. That would give you 40. And you'd have 2 left over. There's different ways you could have done that. But your answer here is 8 remainder 2 as far as mathematically going. But how many crates is that? Again, we need to interpret that remainder. We need to look at what this number is telling us to do. If he's going to put them all in crates, he's going to need 9 crates. Now, in these examples, I rounded all of these up. It may ask you how many full things there are, and then you would round it down. Or you would have, maybe you could do something with the fraction as well. But again, it's asking how many crates. So he was going to need 9 of them to get all 42 pumpkins. The mixed operations section shouldn't be too bad. We're comparing whether we're going to add or whether we're going to multiply. And so whenever we multiply a problem, we're always dealing with things that are in sets or groups, equal groups. That's a multiplication problem. When we're adding, we're trying to find a total number of something, right? So you just have 2 different things. You want to know how much together it is. So that's the difference. So whenever we're doing with multiplication, it's always going to be a set or a group of things. So let's take a look at 3 examples again. This one says, the 4th graders at Cunningham Elementary School voted for a new school mascot. Peter the Penguin got only 7 votes. Timmy the Tiger got 8 times as many votes as Peter the Penguin. I personally would vote for a penguin. I think that's a better mascot. There's a lot of tigers out there. Penguins are a little more unique. That's just me. However, Timmy the Tiger got 8 times as many votes. Quite frankly, this says it right in there. 8 times as many votes. It isn't 8 more votes. It's 8 times as many votes. And so if we wanted to figure out how many votes he's got, we're going to multiply. Keyword right there tells you 8 times as many votes. It isn't 8 more votes. The Tiger didn't get 8 more votes. That would have been 15 total. He got 8 times that. So that'd be 56 votes. So just by reading the clues and using the words that are in there, that can help you figure it out. Let's take a look at another one. This one says, on weekends, Edward bakes muffins for his family to eat for breakfast during the week. Edward baked 6 banana nut muffins last Saturday. He also baked 6 more blueberry muffins than banana nut muffins. What equation can you use to find out how many blueberry muffins Edward baked? So he also baked 6 more blueberry muffins than banana nut muffins. We're not talking about a set. We're not talking about something he did each day for a week. We're not talking about the same thing over a period of time. And so in this case, it's going to be just an addition problem, right? We don't have, it isn't asking he baked 6 muffins for a week. So he did 6 on Sunday, 6 on Tuesday, or 6 on Monday, 6 on Tuesday, 6 on Wednesday. And it isn't that set thing. This is just one day and another day, how many together. So 6 one day, 6 another, your answer is going to be 12. But in this case, it's an addition problem. Let's take a look at another one. Last example. Joel got to choose what toppings to put on his frozen yogurt. He put 1 scoop of strawberry slices. He put 3 more scoops of blueberries than scoops of strawberry slices. So he went into a yogurt shop, got his frozen yogurt. He put a scoop of strawberries on it, and then he put 3 more scoops of blueberries. Then scoops of strawberry slices. So, again, are we dealing in sets of things, or are we just talking about number of scoops that he put on? If you need to draw this out, that would work too. So he went in, here's his bucket of frozen yogurt. He got a scoop of strawberry on there. Great, looks delicious. Now he gets 3 more scoops of blueberries, then scoops of strawberry slices. So in this case, he's going to have 3 more blueberries. So when we do this, he will have the same number of scoops, and then he has 3 more of blueberries. So 1, 2, 3. And this is how many scoops he has. So it asks what equation can you use to find the scoops of blueberries? Well, he's actually got 4 of them, so that would be 1 plus 3. We're not talking about if he got 4 different cones with 3 scoops on each. Then you'd be using a multiplication problem. In this case, it's just a simple addition problem. We're starting with a number, we're adding some more. We're not talking about groups again. So just kind of look for any keywords where they talk about groups or sets, and that'll give you a clue that it's going to be a multiplication problem. If you're just starting with a number and putting some more on top of it, then that's going to be an addition problem. Interpreting line plots. Line plots are something that we did quite a bit in 4th grade, and I think they're pretty straightforward. There's one mistake that a lot of 4th graders make, and it has to do with not remembering the difference between whether something is the biggest number or the most common. And those are 2 different things. Whether it's the biggest number or the most common number, those are 2 different things. The biggest number, we're talking about the biggest, we're talking about the number that's typically the furthest on the side, versus the most common, which is the number that's the tallest. So I'll kind of give you guys a couple of examples here, but keep in mind that's usually the place that most people make their mistake, is not remember the difference between a number being big or being most frequent or most common. So let's take a look at this one right here. This one says, a dietitian noted the number of apples eaten by her clients last week. So here's the number of apples eaten. We've got a title at the top, eating apples last week. So this tells us how many apples they ate. It's just telling us the name of the chart. Charts like people, they got to have a name. This tells us what these numbers are. It's numbers of apples eaten, right? So some people ate 0, nobody ate 1, one person ate 2, and on and on. And this is just how many, right? So my question in this case is, how many clients ate fewer than 2 apples last week? Well, here's 2 apples, right? Right here. It's asking fewer than 2 apples. We're not counting this one. So we're going to start right here. It's all of these. Nobody ate 1, but we've got 1, 2, 3, 4, 5, 6, 7, 8 people ate 0. My answer is going to be 8. Okay. My biggest, if someone asked me what is the most number of apples eaten, the most number of apples is going to be 5. Okay, 0 is the most common number, but 5 is the most, and that's that part where people get tripped up on. Fourth grade struggle with that one. The most number of apples eaten was 5, and 4 people ate 5 apples. The most common number is 0. Those are two different things, right? So as far as talking about the most apples, it's 5. The most common number was 0. But in this case, we're asking 2 or fewer than 2. Not 2 or fewer, but fewer than 2. So 2 is not less than 2. So it's just going to be 1 and 0 in this case. And make sure you read that one correctly as well. So you have to read them carefully. But if you read it carefully and take your time, it really shouldn't be too bad. Let's take a look at this one. Students in Miss Maria's math class guessed a number between 1 and 5 and recorded the results. So again, a title, guessing a number between 1 and 5, number guessed. Which number was guessed the most times? This one's a little tricky because it's 5 because it's the most frequent number. Not because it's the biggest number, right? But we've got it as the most frequent. So it's because it's the tallest number this way, right? It's been guessed 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So 9 different people guessed it. And so 5 is the most guessed number. So I would answer with a 5 here. Okay. Not 9, but 5. What number was guessed the most? 5 was guessed the most. The number 5 was guessed more times than any other number. And also it's the largest, I get it, so that one's a little tricky. It's the largest and most frequent number. One more. Again, read these carefully and it'll be all right. This one says, students in Miss Cohen's class rolled a 6-sided die and recorded the results. So you take some dice, right? Just one of them, you roll it. You're going to get a different number. And you're either going to get a 1, 2, 3, 4, 5, or 6. And here's the results, right? We've got, nobody got a 5. A few people got a 3. A lot of people got a 4. Okay? So, the question is, how many students in the class rolled 4? All you have to do is look at the numbers rolled, go over to 4, and count the number that's here. In this case, it is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 would be my answer. There were 10 people that rolled a 4. So I would use that as my answer. Really make sure you take your time, read these carefully, and it'll help you with it. And don't get mixed up on whether it's the biggest number, the most frequent number. Those are two different things. Really pay attention to how it's worded. So here we're talking about fractions, equivalents, fractions with denominators of 10 and 100. So when we're dealing with fractions, especially with 10 and 100s, I like to talk about money because I think it's something that students relate to a little bit better. If I was talking about a penny, how many pennies do you need to make $1? Well, you need 100 pennies to make $1. When we're talking about dimes, how many dimes do you need to make $1? Well, you would need 10. So any penny is 1/100th of $1. Any dime is 1/10th of $1. Right? So we talk about value of things. Right? So if I said, hey, would you rather have 2 dimes or 15 pennies, which one would you rather have? This would be like 2 out of 10, and this would be like 15 out of 100. Right? Which one's greater? What's the difference in value? Right? Now, 15 pennies might be a lot to carry around. 2 dimes is a little bit easier. But 2 dimes is actually worth more, right? Because this would be worth 20 cents. And 15 pennies would be worth 15 cents. And we all would rather have 20 cents than 15. So we look at the value here. And we're going to be using these these denominators of 10 and 100 to figure these out. So I've got 2 hundreds charts here. What I usually like to think about doing is taking one of them and splitting it into tenths. So instead of looking at the small squares, if I were to divide this out and put a line down each one of them. Now on the left side, I've got a hundreds chart, and now I've created, using green lines, tenths. And I've got these 10 different categories here to do this. So if I were to give you a problem of comparing different things, one might be something like, what is 4 tenths is equal to how many hundredths? Well, if I shade in 4 tenths on here, this would be like shading in 1, 2, 3, 4. How many of these little squares did I shade in? You could count them, but hopefully you know you can just count by tens. You'd go 10, 20, 30, 40, and my answer here would be 40 hundredths. They're the same amount. If I said, hey, would you rather have 4 dimes or 40 pennies? 4 dimes is probably easier to carry around, but they're the same value. They're worth the same amount. You might also get a question saying which is greater, and you would have maybe 2 different numbers like 9 hundredths or 9 tenths, and it asks you to tell you which one is greater. So again, if we're dealing with 9 hundredths and 9 tenths, 9 hundredths would be 9 little squares. It would be like 9 cents. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tenths would be 1, 2, 3, 4, 5, 6, 7, 8, 9, which has more red on it. We're dealing with the 9 tenths does. So 9 tenths is more than 9 hundredths. This would be like 9 dimes. This would be like 9 pennies, which is more. Hopefully you remember that it's 9 tenths. So you might be asked to convert tenths to hundredths, hundredths to tenths, or compare which one's larger. Just try to think about them, either whether it's money or think of it as a chart. You need to shade something in. A lot of you still have the hundreds charts. You could take a look at that and shade them in. But just try to make sure that you use those interchangeably, and you should be okay. Last one, and this is more of a vocabulary one. We're dealing with shapes. We're talking about 3 different terms. We've got parallel, perpendicular, and intersecting lines. So these are all lines, nothing curved. We're always talking about lines. When we talk about lines as geometry, they're always going to be perfectly straight lines, nothing with a curve. Those don't count as lines in geometry. So the first time we're talking about parallel. Parallel, I always remember because it actually has parallel lines in parallel. It's those 2 little L's here, if you look at that. And so those 2 little L's are actually parallel. Parallel is like a train track. They never cross. They're always the same distance apart. These 2 lines, no matter where I measure, are the same distance from each other. They just keep going on forever, always the same distance. They will never cross. So whether you think about train tracks, how they never really cross, they always just go on forever without crossing each other. That's fine. There's the 2 L's in parallel. That helps me remember because there's like a parallel line in there already. Those are helpful. If you think about any like a blackboard or a whiteboard, whenever you think of anything that's rectangular shape, you always have a set of parallel lines here and here. as well as here and here. So this is parallel to this. This is parallel to this. So you've got two sets of parallel lines. Parallel just means they will never cross. They don't meet. They're always the same distance away from one another. When we talk about perpendicular, it is the exact opposite of parallel. So when we have a perpendicular line, these lines actually do meet. So if you've got a line, perpendicular line meets at a 90-degree angle. It's got to be exactly 90 degrees. A perfect T, like a letter T. It's got to meet at that. If it's 91 degrees or 89 degrees, it doesn't count. It's got to be exactly 90 degrees. It's got to have a right angle in there. It's got to be right. A right angle. So this would make it a perpendicular line. So again, if you think about a rectangle, now we do have perpendicular lines. This line is perpendicular to this line, and this line is perpendicular to this line. They meet at a perfect 90-degree corner on this rectangle. If you think about a floor or a tiled floor, you've got a lot of intersecting or a lot of perpendicular angles where they meet at that perfect 90-degree angle. But it's got to be 90 degrees. It's a perfect T. So these are two opposite things. The opposite of parallel is perpendicular. The lines actually meet at a perfect 90-degree angle. Intersecting lines, when we're talking about these, is basically any other two lines, wherever they would meet and they might cross, or they will cross. So for example, if I have a line and another line that crosses it, these lines are intersecting. They cross. All right? It's not at a perfect 90-degree angle. These two lines are different distances depending on where you measure them from. These are intersecting. It can be like that. It could be like this. Anything that makes kind of an X or anything similar to that, if it's not a perfect 90-degree angle, it's going to be intersecting. So these would be different examples. It's anything that meets not at a perfect 90-degree angle. So parallel, keep in mind there's the L's in there. Helps you remember it's parallel. Perpendicular is the opposite of parallel. Intersecting lines just cross. If you think of an intersection of a road where you have different cars coming in, right? They can go in different ways. Sometimes intersections are perpendicular, so that can be kind of tricky, but they don't have to be. So some roads could have a Y intersection like that, and you could go this way or you could go this way, either way. So kind of keep that in mind as well. Intersecting just means it's any shape of line that crosses at some point in time, not at a right angle. So perpendicular has got to be a perfect 90-degree angle. Hey, if this video is helpful, please let me know. I love hearing from you guys. I hope this was helpful. If you still have questions, let me know and I can try to answer them. But also, I did have the other links in there as well, so take a look at those, and hopefully those will answer your questions between this video and the other ones. Otherwise, let me know. I'd be happy to help you out. Hope you guys have a great week, and I look forward to seeing you later. Bye.